in the last video, we have discussed about the concept of center of mass. So in this video, we are going to take this example and we'll try to solve this. So what is this example saying? Find the center of mass of three particles at the vertices of an equilateral triangle. The masses of the particles are 100 gram, 150 gram, and 200 gram, respectively. And each side of the equilateral triangle is 0.5 meter long. Okay, let us draw the situation first. So here we have equilateral triangle and each side is of 0.5 meter. Now, here let's say we have 100 gram mass. Here we have 150 gram and here we have 200 gram. Now, we have to find out center of mass. So let's say this is our first location. So its coordinates are x1, y1, and this is our second location, so its coordinates are x2, y2, and here let's say it is x3, y3. Now we know that we can find out x coordinate of center of mass by m1 x1 plus m2 x2 plus m3 x3 and whole divided by m1 plus m2 plus m3, and then we can get y coordinate of center of mass m1 y1 plus m2 y2 plus m3 y3 and whole divided by m1 plus m2 plus m3. Okay, so here m1 is 100 gram, m2 is 150 gram, and m3 is 200 gram. Now we have to choose reference point. So let's draw Cartesian plane here, and let's say, look, we are free to choose our reference point. We can take anywhere the origin and then we can start this calculation. But when we are free to choose this reference point or reference axis, we should choose it wisely so that our calculation will become easier. So let us draw this reference line here. Okay, let us draw the reference line here. Okay, so this is the midpoint of this side, and then this is our x-axis and this is y-axis. Now we have this one 0.5 meter length. So here x2 will be 0.25, or let me write it 1 by 4 meter. And I'm not writing units. We have this thing understood that lengths are in meter and masses are in gram. So x2 will be 1 by 4, means half of half, that is 1 by 4, and y2 on x coordinate y2 will be 0. In the same way, x1 will be here, x1 will be minus 1 by 4, it is half of half towards negative. So on the x-axis, so 1 by half, 1 by 4, sorry, and then y1 will be again 0 on the x-axis. And what about this x3 and y3? So x3 is this length, x3 is this length from here to here, and we know this length is 0.5 and this length is 0.25. So we can use Pythagoras theorem in this triangle, and then we will have this length square equals to this length square minus this length square. So we can write, if we write here, this is our reference point, that is origin. So this, let me write it, point A, this is point B, and this is point C. So OC square will be here, OC square will be, just a minute. Okay, OC square will be this CB square minus this OB square. And then we will have CB square is 0.5 square, or we can write 1 by 2 whole square. So 1 by 2 whole square minus this one is 1 by 4. So 1 by 4 whole square. So let me write it somewhere else, then we will come back to this. So OC will be the square root of 1 by 2 square, that is 1 by 4, minus 1 by 4 square, that is 1 by 16. And then it will be 4 minus 1 by 16. I hope you are getting how is it going on. And this will be root 3 by 16, or simply you can say root 3 by 4. So getting back to this point, x3 will be here. X3 will be 0 because on the x-axis, sorry, on the y-axis, x coordinate will be 0. So x3 will be 0, and y3 we have just obtained here. That will be root 3 by 4. Now it's time to solve for x of center of mass and y of center of mass. So x of center of mass will be x center of mass will be m1 x1. So m1 is 100 and x1 is minus 1 by 4 plus m2 x2, that is 150 into 1 by 4 plus m3, which is 200 into x3 is 0. Look here, x1 x2 and here x3, m1 m2 m3. Okay, coming back to this position, and then we will have m1 plus m2 plus m3, and then what will be this? 1 by 4 here, 100, negative of 100, and then 150. In case you get confused about the calculation, you should feel free to ask. This will be 450, and then it will be 1 by 4, and here it will be 50 only, and then 450, and then it will be like this, 1 by 5 times 9, 1, 4, 3, 6. 1 by 36 will be x of cm. Now, what is y? Center of mass. This will be 100 into 0 because this is, we have chosen on x axis. Again, 150 into 0. And finally, we will have only one term surviving here, which will be root 3 by 4. And then at the denominator side, it will be 450, m1 plus m2 plus m3. And then we will have, let me try to solve it quickly. So this goes here, and then 5 times 9 and 5 times 4, and then here it will be gone. And then we will have root 3 by 9, and we can write it 1 by, this one will be 3 times 3, and then root 3. Again, I am mentioning, if you are confused with these calculations, so you can feel free to ask how it has been done. So xcm is 1 by 36 and ycm is 1 by 3 root 3. So our center of mass will be somewhere near this point. Okay, let me try to indicate it. X 1 by 33, that is very close to this y-axis, and y is 1 by 3 root 3, and it will be, this is 0 point something, so it will be somewhere here, very close to this y-axis. So this is our center of mass, and its coordinates are uh, 1 by 36, 1 by 36, and then this will be, y will be 1 by 3 root 3. So here 1 by 3 root 3. Okay. Now you may think that in your textbook this example has a solution as this. So why our solution is different? Because we have chosen a different reference point. We have chosen this origin to be here, and this is y-axis in our case. So what happens? We are getting different x coordinate and how much it should differ. So we have shifted this one by 1 by 4 along x-axis. So this example where you are getting solution from the textbook, this solution should be plus 1 by 4 in our xcm. Means we have, look, we have shifted this origin to here. We have reduced the x coordinate by 1 by 4. So if we are trying to match our answer with this given answer, what we need to do, we have to add 1 by 4 in our x coordinate where we have obtained the answer. So what was our x and y coordinate will remain same because we have not displaced or shifted this reference vertically. So y is going to be same, but x will be differing, and this answer will have 1 by 4 more comparing to our case. So where is this? Uh, Here we have x coordinate as 1 by 36 and y coordinate is 1 by 3 root 3, which is compatible with this answer, but x coordinate is differing. Let us try to make it. We have x cm obtained 1 by 36 and we have shifted this entire reference frame by 1 by 4. So we have reduced x by this much. So we need to add this much in our answer in x coordinate to get the matching answer with this. So we can add simply here. Although you do not need to do this. If you have chosen this reference, it is fine to write the proper answer, what we have got. Still, let us try to match it. So this will be 136 and this will be how much? 1 only, and this will be plus 9, and then we will have 10 by 36, and you can simplify it 5 by 2 times 18, 5 by 18, which is given here. So I guess you have got it thoroughly. In the next video, we will see what if we have some symmetric objects, some well-shaped objects, and continuous mass distribution. So in that case, we will try a different approach. So that's all for this video.